Hi everyone. Today we are discussing about the PNP transistor. First, we need to know about the transistor operation. The main operation of the transistor is used to amplify the signals, amplify the waveform signals, and boost the signals and strengthen the signals. In this, we are knowing about the PNP transistor. A PNP transistor is a bipolar junction transistor. Let's talk about the structure of PNP transistor. The PNP transistor consists of two p-type semiconductor materials and one n-type semiconductor material. Uh, the n-type semiconductor lies between the two p-type semiconductor materials, which allows the effective flow of current in the transistor. Let's talk about the terminals. In this transistor, there are three terminals: base, collector, and emitter terminals. Uh, the current flows from the emitter to base with the connection of a base current it depends on the base current because of the PNP transistor which has the majority charge carriers from the emitter and collector or majority charge carriers are holes and while considering the base current, the electrons are the minority carriers. Uh, uh, in other words, to say, the base current has the base current has less number considering to the collector and emitter junctions. Here is a circuit diagram of the PNP transistor where they are uh, two p-type semiconductors and one n-type semiconductor. This p-type semiconductor is considered as emitter, and this p-type semiconductor considered as collector, and this n-type semiconductor considered as base junction. The collector base junction is this junction, and the emitter base junction is this white junction. This is the circuit diagram of the PNP transistor. This is the base junction, and this is the emitter junction. This emitter junction is considered as a P-type semiconductor this side, and this junction is called as emitter base junction. This junction, this junction is called as emitter base junction, and this collector junction is considered as this P-type semiconductor junction, and this junction is considered as a collector base junction. There is a load resistor connected to the IC current. IC load resistor connected to the IC current, which is nothing but a collector junction, and there is a VCC connected to the VCC positive is connected to the emitter, and VCC negative is connected to the collector. Biasing of the PNP transistor. This In this we are knowing about the biasing. There are two types of biasing: forward biasing and reverse biasing. In the forward biasing, the base emitter junction must be in forward bias, which is nothing but emitter has more current compared to the base, and that's why it is called as forward biasing. In this forward biasing junction, the current flows from the emitter to uh, n region. Nothing but the depletion region of the n region will be decreased, and it will become so slim, and the flow of current to the collector is very low because the depletion region is very thin. That's why the electrons cannot jump from the n type region to the collector p type region. uh, in this condition, there is a few electrons jump from the n-type region to the collector, because when there is a signal is applied, both positive signal and negative signal is applied. In the time of the negative signal is applying to the PNP transistor, there is a less current compared to the positive signal is applied. That's why very few electrons jump from the n-type region to the p-type region, which is connected to the collector junction. And next, reverse biasing condition. In this reverse biasing condition, collector base junction will be in forward bias, and emitter base junction will be in reverse bias. This collector base junction is in active mode. That's why the depletion region is very enlarged, and the flow of electrons from the collector, from the emitter to collector is easily through the n-type region. In this reverse bias condition, the electrons are combined with the holes because of the depletion region is very large. That's why it is considered as reverse biasing condition. Um, in this reverse biasing condition, the transistor will amplify the input signal and the efficiency of the signal. Uh, this is the types of biasing junctions, common configurations of including fixed bias. Fixed bias means nothing but fixing the depletion region, which cannot be changed during the forward biasing and the reverse biasing condition, and the emitter biasing condition. In this the current flows through the emitter junction. Nothing but load resistor is connected to the emitter junction, and the voltage divider configuration impacts and the types of biasing conditions is this. Um, as I said earlier, we are knowing about the forward biasing and reverse biasing through this diagram. Let's consider the first forward bias condition. In the forward biasing condition, the emitter has more positive current flows through the emitter compared to the base. That's why the depletion region of the N region is thin, uh, very thin, and the uh, it cannot go when the forward bias is applied. The the electrons from the emitter region goes through the N region and cannot combine with the holes. This is holes and this is the electrons cannot combine with the holes due to the N type. N region is very depletion region of N is very thin. Uh, as I said you, there is a when a signal is applied, there is positive signal and negative signal. When there is a negative signal is occurred, if few electrons recombine with the holes, very less number of electrons recombine with the holes in the forward biasing condition. Okay, next, uh, reverse bias condition. In this reverse bias condition, we are giving we are giving base collector junction. Base collector junction, nothing but we are giving positive terminal to the base. In this base collector junction, the depletion region becomes enlarged, and the flow of electrons to the n-type region is easily, and it recombines with the holes, and the IC current will be in forward bias. That's why we taking the condition IC is equal to IE minus IB. IB is nothing but base current, and IE is nothing but emitter current. In NPN transistor, we take the output through the collector current. That's why the IC is equal to IE minus IB. Because IE current is more than the IB current. That's why we are calculating the IC current to the subtraction of emitter current and the base current. The biasing conditions of the PNP transistor is over, and let's consider about the applications of the PNP transistor. The main application of the PNP transistors are the three applications. Nothing but amplification of the signals. Amplification of the signals is nothing but we use a PNP transistor to amplify to boost the signal strength, because of the when the signal is very low strength, there is a disturbance is occurred. That's why we need to eliminate the disturbance and boost the signal strength. To get the desired output. That's why we use it in an applications. Uh, next, switching circuits. The PNP transistor is also used in switching devices, nothing but controlling the flow of current and input current. Uh, and the next, oscillator circuits. The PNP transistor is also used in oscillator circuits, which is used to generate oscillations in the oscillator when it is connected to the circuits, and it also gives the clock pulses and tones, nothing but the signals, the waveforms of the circuit nothing but AC signal or DC signal. Let's know the compare differences between the NPN transistor and PNP transistor. In NPN transistor, there are two N-type semiconductors and P-type semiconductors. In this region, when the base collector junction is in reverse bias, the base emitter junction will become forward bias, and the output load is connected to the emitter junction. We get the output through the emitter. Nothing but IE is equal to IB plus IC in the NPN transistor. But there is a slight difference to the PNP transistor. We get the output load through the collector junction. IC is equal to IE minus IB. In the carrier types, the PNP uses holes as majority and NPN uses electrons as majority. There is a slight difference. In PNP transistor, majority carriers are holes. In the NPN transistor, majority carriers are electrons. Biasing requirements. PNP requires the emitter to be more positive than the base. As I said, NPN transistor required base. Consider NPN transistor NPN transistor required base positive compared to the emitter. Operational characteristics. PNP handles different voltages levels compared to NPN. As I said, the PNP transistor has an ability to control the voltages compared to the NPN transistors. In this conclusion of PNP transistor analysis, there is some key points. The PNP transistor serves as a white shell component in modern electronics. As I said earlier, we use a PNP transistor in different types of applications like amplification, oscillating applications, and some electronic devices and voltage regulation devices. And next, future trends with ongoing advancement in semiconductor technology, PNP transistor continue to evolve. This PNP transistor is important to the voltage regulation devices and amplification devices. That's why the PNP transistor evolves, and it could not be deleted or kept in a side. When there is a new transistors were invented, but PNP transistor will be considered to the regulation devices, amplification devices, and oscillating generators. And importance of the circuit design. In any circuit design, PNP transistor is used for engineers and designers to perform and ensuring the reliability in electronic devices. Nothing but to get the desired output as we required. We use PNP transistor mainly in any electronic devices nowadays. And this is about the PNP transistor. And thank you.